Well, here we are at the Harden long-term tillage site, which was set up in 1989. We've looked at tillage and stubble retention over this 24 years now, and it's in fact the most relevant cropping pattern of any of the long-term trials in Australia in the last century. It's been a cropping pattern of wheat and canola with some lupins and peas to break the sequences. And the yields of wheat, for example, are 4.8 tonnes per hectare, so it's a properly managed cropping system which removes a lot of nutrients from the ground and is supplied with enough nutrients to keep it going. And the effect of this has been that the soil carbons and nitrogens have decreased quite considerably over the years. And we are saying that this, for the purposes of this study, that the half-life of nitrogen, total nitrogen in the soil, is about 14 years, which is very quick, and it shows that there is a need for a pasture in this system to maintain soil carbon and nitrogen. In the longer term, I think there are some real issues to be thought about. One is, how much do we continue in the process towards continuous cropping, and how much do we maintain the crop pasture sequences? My calculations are that there'll have to be a doubling of nitrogen fertiliser from current levels over the next few decades as soil nitrogen reserves are run down by continuous cropping. If, on the other hand, there's a maintenance of pastures in the system, and my calculations say that about 60% of the farm can be in crop and still maintain soil nitrogen levels at existing levels, then the nitrogen management can continue to be basal applications with MAP and DAP as we do at present, plus tactical applications in response to season and crop conditions and prices. As soil nitrogen levels go down, the crops will start to experience nitrogen deficiency earlier in their life cycle, and so there'll probably be a need for more nitrogen to be applied at sowing. There should be consideration of slow release forms of nitrogen. Now, there's been a lot of promotion of plastic coated products and of products with nitrification inhibitors and urease inhibitors, and they're very expensive. Banding urea and hydrous ammonia in wide bands, say one band for every 2 rows of crop. This means you can get the concentrations of the ammonia or ammonium or urea at very high levels in the soil, and this will inhibit the nitrification by the bacteria, and so you'll get a slow release at a lower price. So I think that's the sort of thing we've looked at last decade, and it might start to have relevance in the future.